Hi guys, today I'm going to be talking about the reactions that we use to prepare aldehydes and ketones. Now in my previous video, if you've watched that, you will have seen that we make aldehydes and ketones from primary and secondary alcohols. But I did imply that there were special techniques that we needed to use, and those techniques are distillation and reflux. So I'd like to talk about those a bit more, please. Okay, so aldehydes are prepared using a technique we call distillation, and this is a really important technique. So we take our primary alcohol and we oxidize it using permanganate or dichromate, but because aldehydes will continue to be oxidized to form the carboxylic acid, we use this technique called distillation to prepare them. Now, distillation is a technique that separates mixtures based on their boiling point. And that is a really important thing to remember, okay? Distillation is just about separation based on boiling point. Now, the reason we use it for aldehydes is because it allows the aldehyde to be removed from the reaction mixture as soon as it's formed, which prevents it being further oxidized to form the carboxylic acid. Now, there's a reason I put that in bold in this slide, and the reason it's in bold is that phrase is a really useful phrase to remember and to use in your exam if you have a question about aldehydes and ketones. Okay, so about distillation and the preparation of aldehydes anyway. So we use this technique because it allows the aldehyde to be removed from the mixture as soon as it's formed. Well, how does it work? We use a setup rather like that shown in this diagram, and it's dependent on boiling points. So the key thing to remember is that the aldehyde has a lower boiling point than either the alcohol or the carboxylic acid. That's the key factor. So what you do is you set up this apparatus basically as shown, and you heat up your ethanol gently in the flask. That's the flask on the left hand side. You heat it up till it is above the boiling point of the aldehyde, but below the boiling point of the alcohol. So let's say the aldehyde boils at 45 degrees and the alcohol boils at 80 degrees, you might heat it up to 50 or 60. So the alcohol's not going to boil, but it's hot. Then you carefully add in the dichromate and acid, the acidified dichromate or the acidified permanganate if you're using that. As that hits the ethanol, it will immediately start to react, which will then produce the aldehyde. Because the mixture is above the boiling point of the aldehyde, it will immediately boil off. It will boil up. The only place for the vapor to go is down that side tube, where there is a cool water jacket, a condenser, which is going to cool down that vapor, allowing it to turn back into a liquid, and it drips then into the second flask. So that way we are separating out that aldehyde as it's forming and before it has a chance to react further and turn into the carboxylic acid. The solution is not hot enough to boil the carboxylic acid even if it was formed. So any carboxylic acid that forms is going to stay in that first left-hand flask, while all the aldehyde, in theory, should boil, condense, and then collect in the right-hand flask. So we've purified and separated that mixture based on boiling point. So that's the use of distillation, and we use it for the preparation of aldehydes. To prepare a ketone, we have a somewhat different process. So for ketones, we've got our secondary aldehyde, and we want to oxidize it, and all we want to do is turn all of our alcohol into ketone. We use a technique called reflux, which is often used to prepare a lot of organic compounds. Now, as you will remember from previous years, I hope, if you want to speed up a reaction, you heat it up. The big problem with organic compounds is that many of them are very volatile, and so they can evaporate. So the technique of reflux is used to heat up the reaction mixture, which allows the reaction to be sped up and means you get more product, but you're not losing any of your volatile products, because all reactants, because you're not going to get very much product, or if either half your reactants have evaporated off before they've reacted, or if your product boils off before you can collect it in some way. So the way this system works is quite similar in some respects. We have a flask with our reaction mixture at the bottom. We're going to heat that solution up, and what's going to happen is the stuff in that reaction mixture is going to start to boil. It's going to evaporate and it's going to head up the top tube, but as it heads up that tube there's a condenser around it, so that's going to cool that gas back down, which is then going to cause it to drip back into the flask, where it's going to heat and boil, evaporate, cool, drip back down, and so it's constantly boiling, condensing, so you allow it to be heated continuously for a long period of time without allowing it to evaporate. And that is the key concept. With this sort of system, you can quite happily heat it for several hours, even days if need be, for different reactions. It's quite solid, it's safe, it just keeps going and going and going. So that is the use of reflux. You can also use reflux to prepare carboxylic acids, to prepare esters, and for various other preparation techniques. Distillation you can also use to purify a product out of a mixture. Okay, so that's what I've got to say about these two techniques. Please join me for my next video, where I'm going to talk about the reactions of aldehydes and ketones.